Hi Year 12, here's our second video for the solutions to the 2024 HSC Maths Extension 2 exam. In this video we're going to look at questions 11 through to 13. Question 11a, find the integral of x e to the x dx. So this is integration by parts. We're going to let u equal x and v dashed equal e to the x. And so u dashed is equal to 1 and v is equal to e to the x. So our integral of x e to the x dx is equal to u times v, so x e to the x. Take away the integral of u dashed v, which is e to the x dx, is equal to x e to the x, take away e to the x, plus c. b. Let z equal 2 plus 3i and w equal 1 minus 5i. Part 1, find z plus the conjugate of w, which gives us 3 plus 8i. Part 2, find z squared. Expanding out, we're going to have 4 plus 2 3s is 6 times 2 is 12i, take away 9, which is equal to negative 5 plus 12i. C, find the angle between the two vectors u and v, giving your answer in radians correct to 1 decimal place. So cos theta is equal to u dot v over the magnitude of u, magnitude of v, and that is equal to 4, take 8, take 14, over the square root of 9, and the square root of 16 and 16 is 32 plus 49. All right, grabbing the calculator, which is here, and put my calculator in radians, which it is not. So there we go. It's going to be 4, take 8, take 14, and then 3 times the square root of 32 plus 49 gives us negative 2/3. And so theta will be inverse cos of negative 2/3, which is 2.3. We want decimal place, 1 decimal place, so 2.3 radians. 11d, evaluate the integral between 0 and pi on 2 of 1 over sine theta plus 1 d theta. Now this is going to be t ratios, so we're going to let t equal tan theta on 2. Let's do those limits. When theta is equal to 0, t is equal to 0. When theta is equal to pi on 2, t is equal to tan pi on 4, which is 1. Alright, so our integral is going to become between 0 and 1, 1 divided by 2t over 1 plus t squared plus 1 multiplied by 2 over 1 plus t squared dt. You'll find all of those on your formula sheet except for this. That's the relationship between d theta and dt. You have to memorize that one. Alright, we've got double decker fractions, so it's 0 and 1. I've got 1 over 2t plus 1 plus t squared, all over 1 plus t squared, multiplied by 2 over 1 plus t squared dt, which is equal to the integral between 0 and 1 of 1 plus t squared all over t plus 1 all squared times 2 over 1 plus t squared dt, cancels, which is equal to the integral between 0 and 1 of 2 t plus 1 to the negative 2 dt, equals 2, and then we've got t plus 1, I'm integrating now to the negative 1 divided by negative 1 in between 0 and 1. Tidy it up, I'm going to bring that negative out. 1 over t plus 1 between 0 and 1 equals negative 2. Putting the 1 in, I've got a half. Take away, putting the 0 in, I've got 1. is equal to negative 2 times negative a half, which is equal to 1. 11e, write the number root 3 plus I in mod arg form. And so remember that r is going to be the square root of root 3 all squared plus 1 squared, so 3 plus 1, which is 2. And tan theta will be equal to 1 over root 3. Theta is equal to pi on 6. Therefore, so this is part 1 here, root 3 plus I will equal to cis pi on 6. Right, part 2. Hence or otherwise write root 3 plus I to the power of 7 in Cartesian, exact Cartesian form. So it's equal to 2 cis pi on 6 all to the power of 7. 2 to the power of 7 is 128. Is that right? I'm just going to check that. 2 to the power of 7. Yeah, shouldn't have doubted myself. Cis 7 pi on 6, which of course is equal to 128. Cos 7 pi on 6 plus I sine 7 pi on 6 is equal to 128 times. Now, 7 pi on 6 is in this quadrant, so both are going to be negative. So we're going to have negative root 3 on 2 minus I on 2. Look, at this point we've got it right, but let's keep going. Negative 64 root 3 take away 64I. 11f, sketch the region defined by a magnitude of z is less than 3 and the argument of z minus I lies between and including 0 and pi on 2. Alright, let's start with this part here. This is a circle centered at the origin with radius 3 units. And it's a dotted circle because we've got no equality sign here. So it looks like this. Now this part here is centered at this point here. Now it's going to be an open circle at that point. My axis back in. So it's going to be an open circle here. Try and draw it. Yeah. And the argument goes between 0 and pi on 2, which is 90 degrees. Now this is inside the circle, and so it's going to be everything in there except for the point 0, 1. 12a, we're given vectors a and b, and in part 1 we're asked to find a dot b divided by b dot b times vector b, and that's of course the vector projection. So we're going to have a dot b is going to be 2 plus 0, take away 12, all over b dot b will be 4 plus 16 multiplied by the vector b, which gives us negative 10 over 20 multiplied by 2, 0, negative 4, which is negative a half of 2, so that's negative 1, 0, 2. Part 2, show that a take away a dot b divided by b dot b multiplied by b is perpendicular to b. Now you could show this geometrically, but let's just do it with algebra. We want vector a, take away this vector projection which we worked out in part 1, and that's equal to 2, 2, 1. And now we want to prove that this is perpendicular to vector b. So we want the dot product to be equal to 0. Dotted with 2, 0, negative 4 is equal to 4, take away 4 is equal to 0. Therefore, they are perpendicular. (12b), use partial fractions to find the integral of 3x squared plus 2x plus 1 all over x minus 1 in brackets, x squared plus 1 in brackets. So we're going to let 3x squared plus 2x plus 1 all over x minus 1, x squared plus 1 is equal to a over x minus 1 plus bx plus c all over x squared plus 1, and this means that 3x squared plus 2x plus 1 must be equal to a x squared plus 1 plus bx plus c multiplied by x minus 1. Right, we'll let x equal 1. That's going to give us 6 is equal to 2a, therefore a is equal to 3. Substituted in that a is equal to 3. So now let's let x equal 0. 1 is equal to 3 plus c times negative 1. So we have got negative 2 is equal to negative c, therefore c is equal to 2. And then finally let x equal negative 1. We've got 3 take 2 plus 1 is equal to 6 plus negative b plus 2 multiplied by negative 2. 3 take 2 is 1, 2 is equal to 6 plus 2b minus 4. And so I think I got b is equal to 0. And that means we can replace the integral with this. This is going to be equal to 3 ln x minus 1 plus 2 inverse tan of x plus c. 12c. Consider the equation modulus of z is equal to z plus 8 plus 12i, and z is equal to a plus bi is a complex number. A and b are real numbers. Part 1, explain why b is equal to negative 12. And so mod z is going to be equal to the square root of a squared plus b squared, and that's going to be equal to a plus bi plus 8 plus 12i. Now you can see here that this is real, and this part's real, and this part's real, and for there to be an equality there, bi plus 12i must equal 0, therefore b has to equal negative 12. To hence or otherwise find z. So from our equation we know that the modulus of z is the square root of a squared plus b squared, and that's going to be equal to a minus 12i plus 8 plus 12i. Therefore, square root of a squared plus 144 is equal to a plus 8, square both sides, equals a plus 8 all squared. A squared plus 144 is equal to a squared plus 16a plus 64. Therefore, 16a is equal to 80, a is equal to 5. Therefore, z is equal to 5, take away 12i. 12d. Explain why there is no integer n such that n plus 1 all to the power of 41, take away 79, n to the power of 40 is equal to 2. So this is a cases question. It doesn't tell you that in the question, so you have to figure that out. And we're going to look at odd and even. So suppose that n is odd. That means n plus 1 is even. And so n plus 1 to the power of 41, powers of even numbers are even. And 79 times an odd number to the power of 40, that's an odd times an odd, that's an odd number. And there is no way that you can subtract an odd number from an even number. So an even number take away an odd number is never going to equal 2. And then we do the other way around. We suppose that n is even, and it's pretty much the same argument. Therefore, n plus 1 must be odd. So n plus 1 being odd to the power of 41 must be odd. And 79 times an even number to the power of 40, so an odd times an even number is an even number, and then the same argument here. And therefore we've proved it. 12e, the line L passes through the points A and B. Part 1, find a vector equation for the line L. So we want a point that lies on the line, which is point A. We write it as a position vector, so 3, 5, negative 4, plus lambda times the direction vector. And I'm going to use AB as the direction vector. So 7 take 3 is 4. 0 take 5 is negative 5, 2 take away negative 4 is 6. And there's our direction vector and our vector equation of the line. 2. Determine, giving reasons, whether the point C lies on the line. So we're going to start with x is equal to 3 plus 4 lambda, and substituting in our coordinate. For x we've got 10 is equal to 3 plus 4 lambda, so 4 lambda is equal to 10 take 3 is 7, lambda is equal to 7 over 4. Now this should be the same for every single coordinate, so now let's do y. So we have got y is equal to 5 take away 5 lambda, and here we've got our coordinate is 5 equals 5 take 5 lambda. And so 5 lambda is going to equal 0, lambda is equal to 0. So because we've got different values for the parameter, therefore C does not lie on the line. Question 13a. The point A has position vector 8i minus 6j plus 5k. The line L has vector equation as shown. Point B lies on L and has position vector pi plus pj plus 2pk. Part 1, show that AB, the length of AB all squared, is equal to 6p squared minus 24p plus 125. All right, so we need to figure out the vector AB. So we know point A has position vector this, so that is OA is equal to 8 minus 6, 5, and we know point B lies on L and has position vector this, so OB is equal to PP 2P. Alright, we want AB, so I'm going to take B and subtract A, that's going to give us P minus 8, P plus 6, 2P minus 5, and now we want the length of that vector squared. So it's going to be P minus 8 all squared plus P plus 6 all squared plus 2P minus 5 all squared. Let's expand all that out. 16P plus 64 plus P squared plus 12P plus 36 plus 4P squared minus 10, 20P plus 25 is equal to P squared plus 4P squared is 6P squared minus 16 plus 12 minus 4 minus 24. So far so good. P. 64 and 36 is 100 plus 25 is 125. 2. Hence or otherwise determine the shortest distance between the point A and the line L. So this is what we have. We have a line, we have a point A sitting off the line, and point B is a random point on the line, and we've worked out the distance squared between those 2 points. So let's minimize that distance by using calculus. We're going to let that distance be D, so D squared is all of that. So D is going to be equal to square root of, so 6P squared minus 24P plus 125 to the power of a half. DD dP is equal to a half, 6P squared minus 24P plus 125 to the power of negative a half times by 12P minus 24. And we want to put that equal to 0. And so in reality, we're going to solve 12p minus 24 is equal to 0. And so 12p equals 24. P is equal to 2. So when P is equal to 2, we have a shortest distance. So D squared is going to be equal to 6 times 2 squared, which is 4, minus 24 times 2, which is 48, plus 125, which is equal to 24, take 48 plus 125 is 101. And so our shortest distance will be the square root of 101. 13b, particles moving in simple harmonic motion described by x double dot is equal to negative 4x plus 1. When the particle passes through the origin, the speed of the particle is 4 meters per second. What distance does the particle travel during a full period of its motion? So let's match this with negative n squared x take c. N is going to be 2, remember it has to be positive, and c, the centre of motion, is negative 1. Now a really useful formula that I would encourage you to remember is this one. It's not on your formula sheet. V squared is equal to n squared a squared minus x squared. And it's really useful because it gives you amplitude. Now we have, this is with our centre of motion being 0, so I'm going to just rewrite that because we have a centre of motion of negative 1. So we want x plus 1 all squared. Right, substituting in this pair of values, we're going to have 16 is equal to 4, a squared, take away x is 0, 1. So we've got 4 is equal to a squared minus 1, and a squared is going to equal 5. So now we're ready to answer the question. So let's just draw up a diagram and have a look at what this thing is doing. Centre of motion is negative 1. We actually don't know where it starts. But let's keep our model simple. Let's say it starts at the centre of motion and it goes in a positive direction. Doesn't really matter. It's going to do this in a full period. Okay, so it's going to come out root 5 and then come back root 5 and then go this way root 5 and then come back root 5. And it's going to do that no matter where it starts, because remember it starts and ends at the same point. So the distance that it travels during a full period of motion is going to be 4 times the amplitude, or 4 root 5. 13c. A particle of unit mass moves horizontally in a straight line, experiences a resistive force proportional to v squared. V is the speed of the particle, so the acceleration is given by minus kv squared. Initially the particle is at the origin with velocity of 40 meters per second to the right. After the particle has moved 15 meters to the right, the velocity is 10 meters per second. Show v is equal to 40e to the minus kx. Right, so we're going to need to integrate this. We've got 3 options. Acceleration, we can make it equal to dv dt. That's not useful to us in this case. We can do v dv dx, which is looking promising, or we can do d dx of a half v squared, and that's not useful. So we're going to use this one. And so let's make that into v dv dx is equal to negative kv squared, and so dv dx is equal to negative kv. Now we need to take reciprocals of both sides, so dx dv is going to equal negative 1 over kv. X will equal negative 1 on k, integral of 1 on v dv, which is equal to negative 1 on k ln v plus c. Initially, the particle is at the origin with a velocity of 40 meters per second to the right. So 0 is equal to negative 1 on k ln 40 plus c. Therefore, C is equal to 1 on K ln 40. So we have got X is equal to negative 1 on K ln V minus ln 40 equals negative 1 on K ln V on 40. So that will give us negative Kx is equal to ln V on 40. E to the negative Kx is equal to V on 40. Therefore, V is equal to 40 e to the negative Kx. Part 2 show that K is equal to ln 4 divided by 15. So we know after the particle has moved 15 meters to the right, the velocity is 10. So let's substitute that in. 15k, and that gives us 1/4 is equal to e to the negative 15k. Coming up here, we have got ln of 1/4 is equal to negative 15k. Now ln of 1/4 is equal to negative ln of 4. It's equal to negative 15k. Therefore, k is equal to ln 4 over 15. Part 3, at what time will the particle's velocity be 30 meters per second to the right? We can't substitute in here because that will give us x, not t. We're going to need to integrate. So we have dx dt is equal to 40e to the negative kx, and so dt dx is equal to 1 over 40 e to the kx. So t is equal to 1 over 40 integral of e to the kx dx, which is equal to 1 over 40 e to the kx over k plus c. Putting in initial conditions. Initially the particle is at the origin, so t is 0 and x is 0. Therefore, c is equal to negative 1 over 40k. And so t is equal to 1 on 40 e to the kx on k minus 1 on 40k. Let's just tidy that up a little bit. We're not going to make x the subject because we actually want to figure out what time is. So that's e to the kx minus 1. Now we don't know what x is. We're going to have to use our previous equation, which was v is equal to e to the negative kx. I think it was 40 out the front. And we're going to need to substitute in v is equal to 30 and solve that. So substituting in v is equal to 30, we get 3/4 is equal to e to the negative kx, and ln of 3/4 is equal to negative kx. Therefore, x is equal to negative ln 3/4 divided by k, which I have worked out up here. So 0.0924. So putting that in the calculator, we've got negative ln 0.75 divided by k. So 3.1128. Now substituting that up into here, it's going to equal 1 over 40 times 0.0924 times brackets e to the, what's k, 0.0924 times 3.1128, take away 1, and we put that all in the calculator and we end up with 0.09 seconds. 15-day last question for this video. It is known that for all positive real numbers x and y, x plus y is greater than or equal to 2 root xy. Show that if a, b and c are positive real numbers with 1 over a plus 1 over b plus 1 over c equals 1, then a root bc plus b root ac plus c root ab is less than or equal to abc. So we're going to make a couple of inequalities and then add them together. So I'm going to start with a plus b is greater than or equal to 2 root ab. And then I'm going to multiply both sides by c. So that's going to give me CA plus CB is greater than or equal to 2C root AB. And then I'm going to say similarly, we are going to have, let me see if I can do this, AB plus AC is greater than or equal to 2A root BC, and BA plus BC is greater than or equal to 2B root AC. Adding all of those together, we are going to get 2 lots of AB plus AC plus BC is greater than or equal to 2 C root AB plus A root BC plus B root AC. Now obviously the 2's cancel. Now we're just going to look at this relationship. Let's put this up here. 1 over A plus 1 over B plus 1 over C is equal to 1, making a common denominator. We have got BC plus AC plus AB is equal to 1, and you can probably see there that BC plus AC plus AB is equal to ABC. So therefore, ABC is greater than or equal to C root AB plus A root BC plus B root AC, and we just need to turn that around to prove what we are required to prove. So we're done. Okay, that's it for this video. In our last video, we're going to cover questions 14 to 16.